Before we start with data visualization, there's one small topic that I would like to address, and that will be useful going forward. Functions. I'm sure you've already heard about this, but let's take a minute to revise a few things. Function, in a nutshell, is a block of organized, reusable code that is used to perform a single related action. Now, the syntax of Python will be def define, the function name, the couple of parameters that we would require, the function suite, and finally return something if required. Now, I have showcased a simple example over here that is, this is something generic for most languages, but I would like to take it to a different level. Let's take a look at this existing example and then we'll move ahead. What I'm doing over here is I'm creating a NumPy array of the size 5 rows and 3 columns. Now that NumPy array is transformed into a data frame which will have the same shape 5 rows and 3 columns. And then I'm assigning the names to the columns as ABC. So list ABC will create a list of A, B, and C, 3 elements. That gets assigned over here. So the df data frame will have column names as A, B, and C. And I'm passing the first column, df of A, to the function, which will actually add all the values in that column and return the value divided by 2. Now this is something very generic, but then let's look into a different example. So let's say we have a Python example. So we'll import pandas as pd, numpy as np. All right. I will create a simple numpy dataset np.array, and let's create a similar example. Let's say 1, 2, 3. Another dataset with 3, 4, 5. Another dataset with some random values like 4, 5, and 6. So this is 3 by 3 data frame. I would need to provide one more level of nesting, and there we go. We have the values ready over here. Alright, so if we export data, we have a 3 by 3 numpy array. I'm creating a data frame out of it. So let's say df is equal to pd.dataframe, and we pass the data into it. Now this creates a data frame. Now the problem is the data frame will have some random column names which will be index based. So if I just explore the values in df, I can see that the column names are 0, 1, 2. So I'll just give a fancy column name over here. Let's say df.columns is equal to list of A, B, C. This is the same example which I had showcased in the previous example. Yes, it looks good now. So if in case you are intrigued by what happens over here, I'll just execute this statement separately. You can see that it actually creates a list of values A, B, and C. And this value gets assigned to df columns. So now df alone will have 3 columns A, B, and C. So it's simple. Now if I access df A, I'll access the first column. There we go. We have 1, 3, and 4. Now let's write a function. The function will be to create a square root of the input value. Let's say define function foo. It takes in a parameter x, and then it returns x square. Probably something very layman, but the idea over here is to showcase how do we use this function in a pandas data frame. Now we just test whether this function works or not. Let's say if we do a foo of 4 and we expect the result 16. Okay, it's actually taking into account 4. My apologies. I just got confused with the... Yes. So in some languages, we use a caret symbol to symbolize the square root, square and square functionality. In Python, it is 2 consecutive occurrences of an asterisk. So foo is a function which returns the square of the input number. So we have passed 4 and we expect 16. And that's it. We have 16 over here. Now, what I would like to showcase is, in pandas, if you have created an external additional function, a custom function, and you are trying to apply that function to a specific pandas column, how do you do it? So generally, let's say you have df.shape, it will be actually 3 by 3. You have 3 rows and 3 columns. we can actually create a new column saying df of d. D is a new column. I can actually add a new value. And pandas internally takes care of assigning 1 to each row in that. That is, you don't need to actually go ahead. If you just explore df, 1 would have already been assigned to all rows. There we go. But what if you want to do something custom? You have to apply a square root or a square on each of the rows over here. Do you still need to go for a for loop? Not really required. That's when we have a df apply function. So what you do over here is you'll say df of a new column, df of d, and we use the apply function. And in this function, we'll apply the foo function. So how this works, we are applying foo on the column d of df. So df doesn't have a column called d. So we'll go ahead and create a new column d. And in that new column, okay, my bad. We'll actually have to provide a column which is already existing. So we provide c. It will take into account the column C and will pass that column to the function foo, and this foo function returns a series where it has applied foo on each and every element of C. So if we just execute the statement, we can see that it has returned 9, 25, and 36, which is a very valid one. So the square of 3 is 9, the square of 5 is 25, and the square of 6 is 36. Now you can actually go ahead and apply this to the new column name. So you have df of t, and you have this function being applied to all the rows. So rather than writing a for loop, iterating and creating something different, you can use an apply function to apply a function across the rows for a specific pandas column. That's it. Short, sweet, and simple. Now let's get started with data visualization.